the first thing that you're always going to do is just factor your denominators, and you're factoring your denominators. So in this case, we have a GCF of 3. And for the second fraction, we have a GCF of just an x. Our next step is we really want to find the LCD, or the least common denominator. The way I approach this is I first ask myself, well, what do they both have in common? When you look at this, they both have an x plus 3 in common, so that has to show up in your LCD. So therefore, we already talked about what they had in common. Now go back and add in anything that is not checked off in your denominator. So as you can see, the 3 in the first is not checked off, and the x. So that is now your complete common denominator for these fractions. Our next step is we want to rewrite these fractions so that the denominators are exactly the same as our LCD. So in order to do that, we really want to multiply the numerator by what's missing. So if you look at this first denominator here, you can tell that we're missing the x from our LCD. So that means we want to multiply the x that's already in the numerator by what's missing. For the second one, we already have the 8, and as you can tell, we have a 3 that's missing. So that's what we're going to multiply that numerator by. Now we can combine these two fractions into one. When you combine them, you just need to write the LCD once, and then we're just going to combine those numerators. So we have an x times an x, which is an x squared, minus 8 times 3 is 24. And you always ask yourself, can I factor that numerator any further? Which we can't. So this is really as simplified as we're going to get, and your last step is to always state what the restrictions are. So looking at the denominator, the restrictions are always going to come from your LCD. So if you look at your LCD, we have 3x times x plus 3. So our restrictions are that x cannot equal 0. That comes from that 3x portion of the LCD. And x cannot equal -3. So why don't you take a second, pause this video, and try number 2 on your own. Okay, so hopefully you took some time to try this one on your own. But just to review, in case you need another problem kind of done out for you, we always start when we're adding or subtracting rational expressions, we always start by just factoring the denominators. So x squared plus 7x plus 12 is going to factor to an x plus 4 times x plus 3. And x squared minus 4x minus 21 is going to factor to x minus 7 times x plus 3. Now for our LCD, I always start by asking myself, what do both denominators have in common? They both have an x plus 3. So that covers this x plus 3 and that x plus 3. And then just make sure you add in anything that's not checked off in your denominator. So that x plus 4 needs to get added in, and that x minus 7. So now we covered everything. And now the next step is to multiply the numerators by what's missing. So I'm going to write this a little differently than we did in the first one. If you look, the LCD is x plus 3, x plus 4, and an x minus 7. If you look at that first numerator, isn't it the x minus 7 that's missing? So that's also what you have to multiply that numerator by. for the second one, isn't it the x plus 4 that's missing? So that's what we were multiplying this numerator by. Now we can start combining. So we're going to combine this into one fraction over that LCD. I'm just going to write out the LCD for today. When you add together the two numerators, you want to make sure you distribute everything. So we have 2 times x minus 7. So that's a 2x minus 14 plus 5x plus 20. Now we can combine some like terms. So we end up with 7x plus 6 over this LCD. Ask yourself, can that numerator be simplified any further? Doesn't look like it can, so we're just going to leave it. And the last thing is to state what your restrictions are. Again, that comes straight from the LCD. So x cannot equal -3, -4, and +7. Up next, we're just going to be simplifying a single rational expression. So as you can see, there's nothing being added or subtracted, multiplied or divided. It's just one fraction that we just need to reduce. So the steps for these types of problems are just factor the numerator, factor the denominator, state the restrictions, and then cancel. So if you're looking at this first numerator, you can see that there's a GCF of a 9xy. And we're left with 6 minus 5x all over a GCF of a 2x squared y, and we are left with 6 minus 5x. So factor the numerator, factor the denominator. Now we're just going to state the restrictions. Now we do have two variables here, so you really want to say what x can't equal and what y can't equal. So looking at from that x squared, we know that x is not going to be able to equal 0. And from this 6 minus 5x, we know that x is not going to be able to equal 6 over 5. And then we're also going to want to state that y can't equal 0, because if y was 0, then the whole denominator would be 0, which would not be good in a fraction. Okay, once you do that, now you can start canceling. So we have 6 minus 5x in both the numerator and denominator, so those can cancel. As you can see, there's a y in the numerator and in the denominator. And now, when you have an x over an x squared, if you want to think of it like this, you have x over x squared is just x times x. And really, doesn't just one x cancel with 1 in the denominator? So there's still going to be one x that's left over in that denominator. So if you want, you can cross this one off, but I just cross out the 2. And our final answer will be 9 over 2 x. So here's our answer, and here are our restrictions. So just like the other one, why don't you pause now and try number 4 and see how that goes. All right, so hopefully you took some time on your own to try this problem. So hopefully you started by just factoring the numerator and factoring the denominator. When you look at the numerator, we have an example of difference of squares, because we have a binomial with a subtraction sign, even exponents, and 9 is a perfect square. So this will factor to 3 minus x and 3 plus x. It's okay that the x is coming second, as long as you factor it correctly and follow the same rules for difference of squares, you should be fine. Denominator, you're going to factor out a 5, end up with 3 plus x. State your restrictions. X cannot equal -3. And cancel. So the only thing that cancels are your 3 plus x. And we're left with 3 minus x over 5. So the last type of problems that we are going to go over are the multiplying and dividing problems. They're very similar to problems 3 and 4, except there's just more factoring to do, and the dividing problem, you have one extra step. But let's start with the multiplying problem. The steps, just like numbers 3 and 4, is that you're really going to factor everything. Factor every numerator and every denominator. So if you're looking at number 5, x squared minus 25 is going to factor to x plus 5, x minus 5, x squared minus 2x minus 15 factors to x minus 5 times x plus 3. For the second numerator, all we have is a GCF of a 5, and we're left with x minus 1. And x squared plus 4x minus 5 factors to x plus 5 and x minus 1. Once everything is factored, before you cancel, state what your restrictions are. So I write them down here so they're out of the way. The restrictions are going to come from both denominators. So x minus 5 shows that x cannot equal positive 5. This x plus 3 says that x can't equal negative 3. Just a reminder, if you're not sure where I'm getting this from, we don't want x minus 5 to equal 0. So what x value will make that equal to 0? That will just be 5 if you just add those 5 over. So you can set each piece to 0 if you're not sure where this is coming from. From the x plus 5, we're going to get negative 5, and the x minus 1, we're going to get positive 1. Now that you've stated all your restrictions is when you can cancel. Anything from any numerator can cancel with anything from either denominator. So you can really cancel diagonally or vertically. So we have x minus 5s can cancel, this x plus 5 with that x plus 5, this x minus 1 and that x minus 1. And we are just left with 5 over x plus 3. So that's our final answer. Here are the restrictions. As you can see, it's really important to make sure you state your restrictions before you cancel. Now let's try a division problem. Division problem, you're going to start the same way. You're going to factor everything. All the numerators, all the denominators. So when we look at the first numerator, we can factor out a GCF of a 2. For this first denominator, we can factor out a GCF of a 4. Oops, excuse me. Let me just fix this real quick. When you factor out a 4, you get 3x plus 1 divided by, factor out a 6. And we can factor out a 3. So we're left with 3x plus 1. Now with division problems, at this point, I state any restrictions that we have. So when you state your restrictions, again, you're just going to be looking at the denominators. And the only restriction we're really going to have is that x cannot equal negative 1/3. That's coming from this 3x plus 1. If you set that equal to 0, you're going to get negative 1/3 as an answer. Now with division problems, you actually turn it into a multiplication problem by multiplying by the reciprocal, or some people like to say keep, change, flip. You keep the first fraction the same. You change division to multiplication, and then you flip the second fraction. Now, because you flipped the second fraction, you now have something new in this denominator, which then creates an additional restriction. So make sure you check your restrictions again. So you're looking at those denominators. We already have the negative 1/3, but now we also have to add a 5 to that list. Once you do all that, now you can start canceling. So it looks like the x minus 5s are canceling the 3x plus 1. Now, you can also reduce some of these numbers. 2 over 4, doesn't that reduce to 1 over 2? 3 over 6, that also reduces to 1 over 2. So if you look, we have 1/2 times 1/2, which actually is just a 1/4, and that's the most simplified form.